friend. My name is Kingsley Linus. I'm here to take you on an interesting subject, mathematics. Today, our theme is titled Algebraic Processes, and we'll be looking at the simplification of algebraic expressions, part 1. I promise you it's going to be an interesting lesson. I'd like you to sit back as we do this together. By the end of this lesson, you should be able to, 1, identify and state the coefficient of a given algebraic term. Secondly, you'll be able to identify positive and negative coefficients. Then lastly, you'll be able to perform basic arithmetic operations on algebraic expression of similar terms. Now, by way of introduction, algebra is a branch of mathematics where we use letters and numbers. Algebra is a branch of mathematics where numbers are used in combination with letters. Okay, just like normal arithmetic, the rules that guide us in arithmetic also apply here in algebra. And in algebra, we use numbers. We have examples 5, 7, 8, and so on and so forth. We also have letters. You can use any letter of the alphabet. We have X, Y, A, D, Z, and so on and so forth. Now, when we talk about algebraic terms, it has to do with the combination of these letters and numbers. And when we talk about the numbers, you know the numbers from 0 to 9, and the alphabets from A to Z can also stand as these algebraic terms. So we combine these letters, they are algebraic terms. For example, we have 2x, 3y, 5q, 7r, 13 over 15t, minus 4 over 9w, and minus 12y. You see, these are products of numbers and letters. By product, we mean multiplication or bringing them together and multiplying them. Okay, you can see 2x is a product of 2 and x. And we have 3y as a product of 3 and y, and so on and so forth. We also have fractions where we have 13 over 15t as a product of 13 over 15 and t. Okay, so we can have as many examples as possible for algebraic terms. Still talking about algebraic terms, we always have two parts, the number and the letter. Every algebraic term will always have a number and a letter. Now, the number that multiplies the letter is usually referred to as the coefficient. Here, we have some examples where we have 3 and x. You can see that the 3 is cycled. The 3 here refers to the coefficient. And here we have minus 4 over 11z, and minus 4 over 11 is the coefficient. Now, moving on, we have a number of exercises here that will enable us see if we have the following or what we've been doing so far. We're going to do this together. I believe you are ready. Okay? Now, we'll be writing out the coefficients of these terms. For the first one, we have 3a. What do you think the coefficient of 3a is? Okay? 3. All right? That's very interesting, isn't it? Now, how about plus 5y? Okay, 5. The coefficient here is 5. There's no need to write plus because a number standing on its own is positive. Okay, then how about this? Minus u. Wow, this should be challenging, isn't it? Okay, when we have a term like this, you realize that there is an invisible one here. So if we are going to be writing the coefficient of this, we'll be having minus 1. Okay. Then moving on, we have 25x. I believe it's easier right now. So we have 25. Then here we have 1 over 3. And then we have 56 here. I believe this is going well. Okay, here we have a negative term. So our coefficient here will be minus 5. And then here we also have minus 4 and 4. And 400 and minus 21 and minus 15. I guess that was interesting, wasn't it? All right, moving on. Now, having seen what coefficients are, let's look at positive and negative coefficients. Algebraic terms could actually be positive or negative. We have a table here where we have a list of algebraic terms. We have 4x, 7y, minus 12z, minus 13q, 4/11r, a, and minus a. Okay, then moving on the table, you realize we have the title decomposition. By decomposition, we mean the components that makes up the algebraic term. For 4x, we have 4 multiplied by x. That's the decomposition of that algebraic term. And then we have 7 multiplied by y as the decomposition of 7y. We also have minus 12 and multiplied by z as the decomposition for minus 12z. We also have minus 13 multiplied by q as the decomposition for minus 13q. We have 4/11 multiplied by r as the decomposition of 4/11r. Here we have 1 multiplied by a as the decomposition for a. There's an invisible one we can't see there, but here in the decomposition we have to show it. Then we also have minus 1 multiplied by a as the decomposition for minus a. Then at this point we are going to tell if the coefficient is either positive or negative. You see, from the algebraic term 4x, we realize that the coefficient 4 is positive. In 7y, the coefficient 7 is positive. In minus 12z, the coefficient is minus 12 and it's negative. We have minus 13 as negative in minus 13q. Then we have a positive 4/11 coefficient, and we have a positive 1 and a negative 1. Now let's go on to look at an example. Okay, still talking about positive and negative coefficients. You know, from the table we saw before now, I believe you must have seen certain situations where we had to put negative signs, okay, meaning that those terms were negative. Furthermore, beyond just having positive and negative coefficients or terms, we could also have whole terms or terms with coefficients that are whole, and then terms with fractional coefficients. All right, we have an example here. It says determine whether the coefficients of the following algebraic terms are whole or fractional. Okay, we'll be doing it together because it's an example. Our first example here, 20c. You see, the number 20 is a whole number. So what we are expected to write here is quite easy. We just write whole. And that means that we have a whole coefficient here. The coefficient here, 20, is whole. And then we also have 7f. 7 is also a whole number. So our coefficient here is also whole. Now, looking at this, we have a fraction as the coefficient. It means our response here, our answer here is going to be a fractional coefficient. The reason is because we have a fraction as the coefficient. We have 4/5, the numerator 4, and the denominator 5. So our answer here, our response to this question is going to be fraction. Okay, we also have a fraction here. We have a numerator and a denominator. So our response to this is also fraction. So this is a fractional coefficient. Okay, we have a whole number and then another fraction. All right, wasn't that easy? I believe you are catching up with the explanation so far and you are really getting what algebra is all about. All right, we have this exercise. I'd like you to try it out. At this point, I would like you to pause the video and try out. The question says, determine whether the coefficients of the following algebraic terms are positive or negative. So all you'll be expected to do is just to write by the side of each of the following terms if they are either positive or negative. All right, I hope you are done. Now let's do it together. Maybe you can do a confirmation to see if you were right. Okay, here we have 20y. It's a positive coefficient, and here we have a negative because we have a minus sign here. So we have negative. Here we also have a negative sign or a minus sign, so we also write negative. Here we have a positive coefficient and a negative coefficient, and then positive coefficient. I'm sure that was quite easy, wasn't it? All right. Having learned about what algebraic terms are, let's go ahead to see what algebraic expressions are. You might ask, what is an algebraic expression? An algebraic expression is the combination of two or more algebraic terms connected together by an arithmetic operator. Let's go ahead to see some examples of algebraic expressions. Here we have an algebraic expression, x plus 2y. You realize that we have x being an algebraic term and 2y, another algebraic term connected together by an arithmetic operator, plus. Okay, so that is an algebraic expression. We also have another algebraic expression here where we have two terms, 3a, 4c, connected by a minus sign. We also have another algebraic expression, 15k and 2n, connected by the division sign or the division operator. And then we also have another algebraic term. This looks a little different because we have two operators connecting the three terms, 3x, 2y, and 3z, connected by the addition operator and the subtraction operator. All these are examples of algebraic expressions. Okay. Still talking about algebraic expressions, we have some important points that will be very good for you to take note of. First, we have that algebraic expressions of similar terms can be added, subtracted, multiplied, or divided. Now, by similar terms, we mean 3x, for example, and 5x are similar terms because they have x and x common between both of them. Okay, so we could actually add 3x and 5x. We can also subtract, we can multiply, and we can also divide this term because they are similar terms. When we talk about similar terms, we also mean terms that are in the same variable. By being in the same variable, just like I mentioned earlier, has to do with having similar letters. You know, we refer to the alphabet as the variable. And what do we mean by variable? A variable is a symbol for a number we do not know yet. It is often a letter like X or Y. So X or Y can stand as a variable. It could be any other letter of the alphabet. Now, addition of algebraic expressions with similar terms. We have some examples here. We are asked to simplify the following expressions. Now, doing that, we'll be doing that together. We have similar terms here. Number one, we have R in so many places. So I believe it's going to be an easy task. So I'd like us to do that together. We want to simplify this. We actually want to do an addition. So we are going to count the number of R's we have. That we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So our answer to this question is going to be 9R. Okay, I believe you understood how I just got this answer, 9 R's. Okay, moving on. Question 2 says A plus 2A plus 3A plus 5A. Now, whenever you are handling questions like this, I'd like you to assume these letters probably stands for something you know, maybe a fruit, for example, apple. So we could say one apple. A here stands for just one apple. There's an invisible one we cannot see, okay? So one apple plus 2 apples, that's 3 apples. Then plus another 3 apples, that should be 6 apples. And then plus another 5 apples, that would be 11 apples. So our answer here, are we going to write 11 apples? No, we have 11A. 11A. Right? Now we also have another situation here. We have 6AB plus AB. Now AB here just represents 1. Okay, so we have 6 plus 1, that will be 7AB. I'm sure you are following. All right. Now here we have a situation that looks somehow. We have 3ABA plus 4AAB plus 5BAA. What do you think? Could this be similar terms? That's 3ABA, 4AAB, and 5BAA. What's your opinion? Okay, I'll tell you. As long as we have an A and an A, another A, an A and another A, and then we also have just one B, and one B, we can actually say all 3 terms are similar. So we can go ahead to add them without any issues. Okay, so doing that, we have 3 and 4 and 5. So we pay attention on the numbers, 3, 4, and 5. When we have 3, 4, and 5, we want to put them together. We'll be getting 3 plus 4 is 7, and then plus 5, we have 12. So our answer to this question is going to be 12 A, B. So I'd like you to also understand here that whatever order you choose to use, as long as you still have 2 A's and a B, your answer will still be correct, in as much as the coefficient is correct, and then you have all the terms represented. Okay, then finally we have 3xy plus 2xy and then plus 4xy. And just like we did in the previous situation, we can just go ahead and put the coefficients together. 2 plus 3 plus 4, that will give us 2 plus 3 is 5 and 4, we have 9. Our answer here is going to be 9xy. Okay, so that's our answer to this question. All right. Now let's look at subtraction of algebraic expression with similar terms. Previously we did addition, but this time around it's going to be subtraction. Okay. The example says simplify the following. Question 1, we have 6a minus 4a. Okay, just as the rule of subtraction holds, we have 6 minus 4. That will give us 2a. So 6a minus 4a is equivalent to 2a. Moving on, number 2, we have 4p minus 2p. 4 minus 2 by the usual subtraction is still 2, so we have 2p. Now at this point, let's get this clear. When we have small letters, we make sure we maintain small letters even in our answers. Like you can find here that we have small letter A and small letter A, so we use the same small letters in our answers. Okay, I'm sure that's clear enough. Okay, now moving on to the third question, we have 3xy minus 2xy. Okay, what do you think the answer to this is? I guess 1xy, isn't it? okay? But by our rules in mathematics, we don't need to write the 1. So we have x, y as our answer to question 3. Then moving on to question 4, we have 10mn minus 7mn. That will give us 3mn. Question 5, we have 8bd minus 3bd. That will be 5bd. Okay? Then moving on, 5bd minus 4bd will give us 1bd, isn't it? But instead of writing 1bd, we will just write bd. So bd is our answer here. All right. Now we have combined operations of algebraic expression with similar terms. Here we have more examples. You know, we've had examples, but this is a combination of what we've had. Both the positive and the negative operations are involved in what we have here. The example says simplify the following expressions. Here we have 6x plus 4x plus 3y minus 2y. Okay? Ordinarily, the 6x plus 4x would give us 10x. And then we have the 3y minus 2y, just like saying 3 minus 2. That will give us 1y. And remember what we said previously, we'll just write our y. Okay, so that's just the solution to the first example. Now moving on to the second example, we have 3c plus 4c plus 6d minus 2d. In this situation, you realize we have two variables, c and d. So we put together the terms in c and then the terms in d, then we get our result. Now doing that, we have 3c plus 4c. That will give us 7c. Then we also have 6d minus 2d. That will give us 4d. Then we put it together with our operator in the middle, which is the positive sign. Okay, so that's the answer to question 2, 7c plus 4d. Then question 3 says 3abc plus 2acb minus 3cab plus bac. Now looking at this, one might be easily tempted to go into a confusion looking at the terms we have. But I like us to remember something I said earlier. As long as we have similar variables represented in each of the terms, we could actually say they are like terms. Now, what do I mean? Here you realize we have A, B, and C. Irrespective of the order, we also have A, B, and C. Same thing here and same thing here. So we can say they are all like terms. So we can go ahead and carry out the operations that are here. So putting this together, we have 3abc and 2acb. We can put it together to have 5abc, and then we bring down our minus 3cab and then the plus bac. Now putting these two together, 5 minus 3, we have 2abc, and we still bring down our bac, so we say plus bac here, and then when we add the two of them, we'll come up with our final answer, 3abc. Now going to question 4, we have 3p plus 4p minus 2p. Okay, 3p plus 4p will give us 7p. Then we go ahead to take away our 2p, and that will give us an answer of 5p. The next example, question 5, we have 2p minus p minus p. Okay, so 2p, we bring down our 2p, then the minus p and minus p is like bringing two negative signs together. So we're going to have minus 2p. Then we put them together, and that gives us an answer 0. Next, question 6, we have ABC, BAC, CAB, minus BCA, and minus ACB. I'm sure you're already familiar with situations like this. that when we have A, B, C in any order, as long as all the variables are represented, we are good to go. So having ABC and BAC and CAB all positive, we put them together to give us 3CAB. The order is not a problem at this point. Then we have minus BCA and minus ACB. When we put these two together, we come up with 2BAC. So from this point, we can do our subtraction. 3 minus 2, that's our major focus. Take note that we have the same variables represented in both terms. So we have 3 minus 2, and that will give us 1ABC. But as we know, we'll write ABC. And finally, on the last question, we have 45G divided by 15G. Now, to do that, ordinarily, we can just go ahead and divide 45 by 15, and that will give us a 3. But you realize that we have a G up here and a G up here, and we can go ahead by canceling this, and then you realize that we will have just 3 as our answer. Having solved all this, we've come to the end of today's lesson. But before we go, we'll take a summary of all we've learned so far. Come with me. We learned that, firstly, algebra is a branch of mathematics where numbers and letters are combined following normal arithmetic rules. We also learned that algebraic terms refer to the combined numbers and letters. For example, we have 2x, 7r, 13 over 15t, minus 12y, and so on. Next, the coefficient of an algebraic term is the number that multiplies the letter. Okay, we also learned that a coefficient could be positive or negative. Going on, we learned that in an algebraic term, the letter multiplied with the number is known as the variable as well as the unknown. Also, we learned that an algebraic expression is formed when we combine two or more algebraic terms, connecting them with one or more arithmetic operator. And finally, we learned that arithmetic operations like addition and subtraction can be carried out on algebraic expressions. Don't be in a hurry to leave. Let me see how much you've learned so far with this exercise. The instruction says, write true or false for each of the following algebraic statements. A, 4x and 6x are similar or like terms. So all you need to do here is to either write a T or an F to indicate true or false. The second question says 6xyz and 11xyz are unlike terms. So you either state T or F. C, we have if x equal to 4y plus 3y, then we get x equal to 7y. D, we have h equal to 13r plus 8r minus 9. We get h equals to 12r. And lastly, for E, you don't have to write true or false. Simplify 8x plus 2y plus 7x plus 5y. Now let's do this together. A, we have 4x and 6x are similar or like terms. That's true. So we have T. B, we have 6xyz and 11xyz are unlike terms. That's a false. So we write F. Then we have if x equal to 4y plus 3y, then we get 7y. That's true. So we have T. Then we have D says H equal to 13R plus 8R minus 9. We get H equal to 12R. That's not true, so we write false. And here for E, we are meant to simplify 8x plus 2y plus 7x plus 5y. Don't forget, we have to bring together the like terms. 8 and 7x are like terms, and then we have 2y and 5y. So putting this together, 8 plus 7 will give us 15x, and 2y plus 5y would give us 7y. This is where we come to the end of this lesson. I believe you now know how to simplify algebraic expressions and what algebraic terms are. See you again in another interesting math lesson. Bye-bye.